Welcome back to part 2 of Module 7, Lesson 3, which deals with graphs of relationships. We're going to start off this part with a video on how to write an equation from a graph.
The graph shows how the cost of renting a canoe is related to the number of hours the canoe is rented. You are asked to write an equation from the graph that could be used to determine the cost C in dollars of renting a canoe for H hours. Begin by identifying which variable is independent and which is dependent. The cost of renting a canoe depends on the amount of time the canoe is rented. So, the time in hours, H, is the independent variable, and the cost in dollars, C, is the dependent variable. Next, find ordered pairs on the graph of the relationship. The graph includes the ordered pairs 1, 15, 2, 25, and 3, 35. Use the ordered pairs to make a table of values for the independent and dependent variables. Finally, use the table to write the equation. The rule is 10h plus 5. So the equation that can be used to determine the cost C in dollars of renting a...
Now I should add that the way they got this information here, I believe that was lesson 7-2, where we took the information from a table or a set of ordered pairs and turned it into a mathematical expression.
A canoe for H hours is C equals 10h plus 5.
Yeah, there you go. Nothing to it. Easy math. Let's see if we can put some of that in practice ourselves. In example 2, they want to talk about Martino and said that he constructed a graph that shows the height of his cactus after several years of growth. Assuming the cactus grows at a constant rate, write an equation from the graph that could be used to find the height H of the cactus after G years of growth. I would have used Y, but they use G, that's okay. And you can see, for starters, they gave us a broken bar graph here because they started off at year 1 with their information, and the cactus was already 42 inches tall at that point, which is a pretty darn tall cactus. From there, they went continuing up for each year to the 2 years was 44 inches, and the 3 years, well, that's going to be 46 inches. So the first thing I'm thinking we need to do, of course, is establish our independent and our dependent variables. So the graph shows relationship between time and height of the cactus, where the time is going to be your independent variable because your x-axis is always your independent variable, and the height, that's going to be your dependent variable because the y-axis, that's always going to be your dependent variable. Now that we have those established, the next thing we need to do is come up with our ordered pairs. So, for the ordered pair for 1 year of growth was 42 inches. We'll put a 42 right there. And then 44 inches took place at 2 years of growth. We'll put that right there. And then 3 years of growth was 46 inches, so we're going to put that right there. That's the ordered pairs we're going to use, and that's what we're going to need to have to find the foundation of solving the rest of the problem, figuring out what mathematical expression will get us to this information. So from here, they're going to take and make a table of the data. Remember, the data is represented in the ordered pairs that you see up here in the What You Know section. So let's go ahead and highlight that because that's some important stuff. So 1 year of growth was equal to 42. 2 years of growth was equal to 44. 3 years of growth was equal to 46. So we've taken that data from the ordered pairs and converted them into a table. And now we get to take, that should be a 44 right there. Now we get to take the data from the table and create an expression for it. First thing I want to look at here is what is the difference between each of these? Each one is increased by 2, and that tells us that we're going to take the years of growth, G, multiply it by 2, and then add something to it after that, maybe. So from here, we're going to take and work on writing the equation. Now, as we said through, the values of the dependent variable increase by 2 each year. So from there, that one checks. That means that after multiplying by 2, we're going to have to add to obtain the correct value for h. And so what are we going to have to add? So let's see here. 1 times 2, that's going to be 2. And then 2 plus what is 42? That's going to be 40. If we do the same thing, 2 times 2 is 4. 4 plus what is 44? That's going to be 40 as well. And you'd have the same plus 40 right here. So with that information, we have everything we need to create our expression. And you can see that expression listed right there. 2 times g plus 40. That's going to be the expression that we're going to use to find the height of the cactus after a certain number of years. So from here, let's see what they do. The final thing is your equation. The height of the cactus is equal to 2 times the number of growth years plus 40. And that's going to be your final equation. From here, we're going to get the opportunity to do one of these on our own, I suspect. Don't really care about that, talk about it. So what you need to do is pause the video, take a look at the magazine sales chart they give us right here. From the chart, first thing you're going to have to do is come up with your independent and your dependent variables. After you do that, then you're going to have to come up with your ordered pairs. After you come up with your ordered pairs, then you're going to have to come up with your table. After you come up with your table, then you're going to have to come up with your expression. And after you come up with your expression, only then are you going to get to write your final equation. So pause the video and work on this. First thing we have to do is come up with the independent and the dependent variables. Well, the independent variable is always the x-axis, which in this case is going to be m. Your dependent variable is always the y-axis, which in this case is going to be c. Now we're going to need to write some ordered pairs. So my first ordered pair is going to be 120. The second ordered pair is going to be 225. Put that in parentheses. The third ordered pair is going to be 330. And the fourth ordered pair is going to be 4. Oh, got myself distracted. 35. So there's my ordered pairs. Now I have that done, we're going to create ourselves a table of the data. So in my table of data, I'm going to take and first put up my columns for my different things. My input is going to be my M, my output is going to be my C, and I need 4 rows in my table here. So where X or M was 1, the C value was 20. Where M was 2, it was 25. Where M was 3, it was 30. And where M was 4, it was 35. So we're off to a really good start here. Now, we need to figure out what is the difference between these points. And you can see every time we jumped, we had a plus 5. So we know that since we had a plus 5, we're going to start off with 5 times m. That's going to be the first piece of our expression. After the 5 plus m, 5 times m, well, let's see, if I did 1 times 5, I would have 5, and 5 plus what is going to be 20? Well, that's going to be 15. So that might be my expression, but let's find out for sure. 2 times 5 is 10, and 10 plus 15 is 25. That worked again. 3 times 5 is 15, and 15 plus 15 is 30. It worked again. 4 times 5 is 20, and 20 plus 15, that's 35. It worked again. So the expression is right here, but it didn't want an expression. It wanted an equation. The equation, the output is C for cost, is equal to 5m plus 15, and that is what our final answer is going to be. So we're going to jump over to where that one's going here, and we're going to put in our cost is equal to 5 times m plus 15, and check, and the answer checks. That is going to be it for this lesson. You all get started working on your homework. Bring any questions you have with me to class tomorrow so I can go over them with you. Have a good night.